5.1 Extreme values of functions.
I don't like the word extreme.
That's a little extreme, Virginia.
Well, that would be if I said I hate it.
That's still extreme, Virginia.
Alright. The first thing is absolute or global extreme values. So the definition for this is let f be a function with domain D then f of c is the A absolute max value on D if and only if, that's what IFF is, f of x is less than or equal to f of c for all x as an element in the domain. Or B, it's an absolute minimum value, absolute min, on D if and only if f of x is greater than or equal to f of c for all x as an element of the domain. And this stuff is often called absolute extrema. So we have a theorem, it's called the extreme value theorem. And it says if f is continuous on a closed interval a to b, then f has both a max value and a min value on the interval.
Maybe you have to want a little more. I already done that one, Josh. I just started writing part B.
It's alright.
My hands are cold and don't write fast.
Your hands cold?
Yes, from being outside still. I'm still like defrosted.
You need one of these.
What is that?
It's an electric hand warmer.
I think Josie had one of those. Oh, it's alright. Yeah, I'll hold it in this hand and it'll like go over.
Transfer to the other one? Yeah, I love those things.
too. 'Cause, like,
It's
the
like
little-
$10. They're not expensive at
Yeah,
all.
it's not bad.
And it also will charge your phone if you need to.
That's actually not. 'Cause, like, the little hot hands get so, like, unhot in, like, a second.
Yeah, well, and these ones you can change the temperature on them too. Like if you push the button, it'll change like how hot it is and stuff. On the and then you can like turn it off and on like as you need it. It's really
I have
nice.
to get one of these, especially for when I go to, like, Christmas town and stuff.
You sound like you're really enjoying that, Virginia.
Yeah.
Are you in the green now?
I am in the
Okay.
green.
Virginia's green.
Yeah.
The next thing is the local, or sometimes you'll hear it called relative extreme value. Definition of that. Let C be an interior point of the domain.
It's like beam.
What?
Beam.
Oh. Of the function f, then f of c is a local max value at c if and only if f of x is less than or equal to f of c for all x in some open interval. What? Oh, containing c. Are you in the purple?
Yes.
Okay. I just split it up and I was like, I probably should check.
I just got here.
And then B, a local min value at C if and only if f of x is greater than or equal to f of c for all x in some open interval containing c. One page down.
How many pages of notes did you say there were?
14.
Okay.
Well, not just notes. That includes examples, but
How many pages of notes?
there's 2 of the non-easy to understand, and then easy to understand has 1, 2, 3, 4.
Did you forget me?
Yes, I
That's
did.
fine. Just when you're done.
Okay. 5, 6,
Is this front and back? That you're counting.
7, 8. You can see why we're doing this.
Yeah. Are we probably doing this Monday too?
Oh yeah, for sure. Virginia thinks we're gonna do 10 pages of notes today.
And I'm stuck on like I'm like 5 minutes behind everyone else.
I mean, I had to go back to
I'm literally
A where I forgot to write the word value. Pretty sure that has some value.
Yeah.
Yeah.
Get
It
it?
makes you feel bad I'm only on part A.
I mean, I still have B those. Oh, done.
All right, under this, trying to kind of color code this so that you can see what all goes together, but this is like a side point to the definition, so I'm doing it in a lighter purple. A function f has a local max or local min at an endpoint C if the appropriate inequality holds for all x in some half open domain interval containing C This is also called local extrema or relative extrema. Now, absolute extrema are also local extrema.
That's good to know.
But not the other way around. Like all local are not absolute, but all absolute are local.
Makes sense to me. Does it make sense to you, Virginia?
I'm just writing.
A list of local extrema should include absolute extrema. Are you done with the dark purple?
I'm in the middle of that area. Oh yeah, I'm done with dark purple.
Okay. All right, so that all just told you what's what. So now we'll talk about actually finding them.
Yeah, shall find stuff.
So finding extreme values. Whoa, if I can spell extreme.
How did you spell it?
It left out the X.
Extreme. Extreme values.
So the theorem for local extreme values if a function f has a local max value or a local min value, how far into the light purple are you?
I'm on the second little arrow.
That one?
Okay.
Let's see, or a local min value at an interior point C of its domain and f prime exists at C, so the derivative exists at C, then f prime of C is equal to 0.
I love it when things are just equal to 0. Just feels so complete. Well, maybe not complete because there's nothing.
So we're going to have some definitions first of a critical point, which is a point in the interior of the domain of a function f at which f prime of f prime is equal to 0 or f prime does not exist. And I often will write does not exist as dn, oops, I can't write that over there, as dne is a critical point of f. Are you done with the purple?
Yes.
A stationary point is a point in the interior of the domain of a function f at which f prime is equal to 0. It can be a min, max, or inflection point, which obviously you know what mins and maxes are, I hope. But if I'm scrolling too far, Virginia, let me know. A inflection point,
How many lines will this definition take?
2 tops. If you have 1, you probably will fit it because you write smaller than I do.
Okay.
And this is the last thing, so you probably don't want this on its own page.
Yeah.
The inflection point occurs where concavity changes, meaning f double prime is equal to 0. I smushed it in there. So then this is basically, if you went through and read the book, this would be like the summary of those notes. The other notes that I'm going to give you, I've essentially read through both prep books and have pulled and made the notes easier to understand. This is kind of like a general overview, but like this doesn't really explain to you how to go about finding stuff. Like a lot of stuff, it's going to be take the derivative, set it equal to 0, and solve. Or take the second derivative, set it equal to 0, and solve, or whatever, or find where this is equal to 0 kind of thing. So that's going to be a lot of what we're doing, but there's just easier ways to understand, and there's like step by step, which like they kind of found last year to be more helpful, which is why I went back and did that. So we'll do those on Monday.